And here we go. We have the series e to the minus n squared. So I'm going to compare this to a known series. This series looks like a geometric series if this part was n, if this exponent was n, but it's not. So I'm going to call this series to be series an, okay, and from 1 to infinity. And now I want to make it look like, well, since it looks like a geometric series, I want to compare that to a geometric series. So the question is like, what is the relationship between e to the minus n squared and e to the minus n? Okay. Well, first of all, well, we're talking about n's greater than 1. Okay. First of all, n is always less than or equal to n squared if n is greater than or equal to 1. Like, for example, 2 is always less than or equal to 2 squared, which is 4. 3 is always less than or equal to 3 squared, which is 9, right? So on and so forth. How about this? Then the minus of this has to be less than or equal to minus of n. So we switch the roles, right? Minus 9 is always less than or equal to minus 3. Minus 4 is always less than or equal to minus 2. Okay, this is true for all n, okay? So then if this is a number less than this one, and in terms of the exponents here, e to the negative n squared is going to be less than or equal to e to the negative n, right? Because this is going to be a smaller number, so a smaller exponent, okay? So then I can put the summation back here. Here we go. I just showed that there is a relationship between the series e to the minus n squared and e to the minus n. And e to the minus n is a known series, okay? In fact, it is a geometric series, okay? So let's rewrite that. Let's rewrite this. N from 1 to infinity, 1 over e to the n, but I can write it as like 1 over e to the quantitative power n, okay? And remember that e is a number around 2.71, so 1 over that is going to be a number less than 1. So here I have a geometric series with the ratio 1 over e, which is less than 1. Okay, and we know that geometric series with ratio less than 1 is convergent. Okay, so especially this geometric series is convergent. Okay, so I can go ahead and just say that this is less than, let me just clean this part, less than infinity, so that since this sum is less than infinity, something smaller than that, this sum is smaller than the geometric series, that has to converge. Okay, we're using now this property here, right? If Bn converges, then An converges. Here we go. Okay, so then I can go ahead and conclude that this series is a convergent series. So in direct comparison test, it's your task to find the second series. And once you sort of like guess what the series is to compare to the given one, then it's your task again to prove the inequality in between. Okay, once these two are done, then you can just get to the conclusion of convergence or divergence of business. Okay, I think that ends the video. Thanks for watching. I'll see you in another video. Bye.